Good evening. Welcome to the ICSE Class 10 Physics tutorial. The topic is continued, refraction at plane surfaces. Today it is part 2. And we start from critical angle. So the first question for today is define critical angle. Now have a look. Look at this figure. HE, see this surface, HE, this line, this surface. Below HE, it is glass, denser medium. Above HE, it is air, rarer medium. Now look at this AU, or before that you see this point O. O, we have taken a point, the point of incidence. At the point of incidence, we have drawn a normal N dash. Alright? So once again listen, HE or EH is the plane. Below EH, it is glass, denser medium. Above EH, it is air, that means rarer medium. O is a point, the point of incidence. At O, we draw normal N dash. Clear? Now we take AO, one incident ray in the denser medium. Why denser? Because this is glass. We are taking this as glass. This is glass. So AO is a ray of light which is traveling from denser medium to rarer medium, from glass to air. Now from A to O, it travels in the denser medium. Now at O, now it has to suffer refraction because both the mediums are transparent medium. And now the AO has to travel from denser medium to rarer medium. So it will suffer refraction. You know the definition of refraction? Alright. Now because it travels, in this case, AO, the incident ray, travels from denser medium to rarer medium. So it goes away from the normal. Away from the normal. The actual path of AO is this. See this is this straight, because the light travels on a straight line path, so it goes straight. It should have gone straight, but it suffers refraction and it is going away from the normal. So AO, for the incident ray AO, the corresponding refracted ray is OD. Okay. And the angle of incidence is this, angle AON dash, this angle in black. That is the angle of incidence. Okay. I have taken only 3 rays because if I take more than 3 rays, then the diagram will be very busy, untidy. If you want to take more than 3 rays, suppose we are taking one more ray here in between. Alright. Any other ray in between here. Now it travels from here to here in the denser medium, and then it suffers refraction and goes like this. Right? Okay. Now the next ray that I want to talk about is BO. BO is another incident ray in red. You see in red. BO is another incident ray. See the angle of incidence, BON dash. Alright. Now for this BO, incident ray BO, the refracted ray is OE. So what will be the corresponding angle of refraction? You can see it is 90 degree. So for the incident ray BO which is traveling in the denser medium, the corresponding angle of refraction is 90 degree in this case, and the refracted ray is traveling along OE. Alright. In between there are many rays. As I told you, I have taken only 3 rays because then the diagram will be untied, maybe. You can take in between so many rays, no? So in between, suppose you are taking 1 ray, so it is going like this. Another ray, it is going like this. Another ray, it is going like this. So a situation will come when for a particular incident ray, the refracted ray will move along this surface OE, making an angle of refraction of 90 degree. Alright. Gradually the angle of refraction is increasing. Suppose this is 30, for the second ray it may be 35, for next ray it may be 40, for next ray it may be something else like that. So gradually the angle of refraction is increasing. Now we consider the situation when the angle of refraction is 90 degree. Angle of refraction is 90 degree. Why is this angle of refraction? Because this is the angle between the normal and the refracted ray. So this is the angle of incidence, angle of refraction. And what is the corresponding angle of incidence? This angle in red. See this angle. So for this angle of incidence, for this ray BU, the corresponding refracted ray is this. The corresponding angle of refraction is this, which is 90 degree. Alright. So this angle which is in red, this angle BON dash is called critical angle. It's called critical angle. Now can you define now critical angle? This angle BON dash, angle BON dash. Alright. Angle BON dash, this is critical angle, and we represent critical angle by the letter C, or IC also we write down. IC. Either like this or with the help of this letter C, capital C. So angle BON dash is C, critical angle. This angle is not critical angle. Now this angle is not critical. Which this angle? See, there are 3 angles. One is AON dash, right? One angle is AON dash. Second angle is BON dash. Third angle of incidence is CON dash. Out of these 3 angle of incidences, because there are 3 incident rays. So for this incident ray, this is the angle of incidence. For this incident ray, the red color. In the red, the angle of incidence. For this 3 incident ray CO, this is the angle of incidence. Out of these 3 rays, or the angle of incidence, the red color you see, for this angle of incidence, the corresponding angle of refraction is 90 degree. Alright, so this angle has been given a special name, and that name is critical angle. So this angle is critical angle. Angle BON dash is critical angle. Now can you define? I hope you should be able to define now. I am defining, you just listen. Critical angle is defined. I am answering the question, what is critical angle? Or define critical angle. Answer. Critical angle is defined as the angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degree, and it is represented by C, capital C, or IC. Hope it is very clear. Alright. Critical angle is defined as the angle of incidence in the denser medium, the red one, angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degrees. So this angle is called critical angle. Okay. Now look at the figure once again. See the incident ray CO. and the angle of incidence CON dash. Is CON dash greater than BON dash? Yes. That means the angle of incidence in this case is more than the critical angle. And now what's happening? That also you see, that you observe. Yeah, be vigilant, observe what's happening. Then you can define on your own. So when for this incident ratio, you see that the angle of incidence is more than the critical angle. The red one is critical angle. BON dash in red, that is critical angle. And in blue, this is angle of incidence, the third case. And this angle of incidence is more than the red one, critical angle. So what's happening then? That is important. You observe what's happening. This is the corresponding reflected ray. Reflection is taking place. OF, the ray of light is getting reflected along OF. So can we say that because the angle of incidence in the denser medium is more than the critical angle for the given pair of media, and that is why the ray of light is totally internally reflected back. Can we say that? Yes. And this is only TIR, total internal reflection. This only we call total internal reflection. So we learned a new term, total internal reflection. Total internal reflection. TIR, total internal reflection. Now the next question is conditions for TIR. What are the conditions for the TIR to take place? What are the conditions for TIR to take place? You don't write down in short form. You write full total internal reflection when you are writing in the examination. All right. So what are the conditions first? And both the conditions are here only. That's why I tell you, in physics, if you pay attention, if you know the concept, if you focus on what is taught, then there are so many things which you need not learn by heart. Automatically, you will be able to write down those things, the definitions or laws. Whatever. See, like here, see, what are the conditions? I'm not going to mention any new conditions. Both the conditions we discussed. The first condition is the ray of light should travel from denser medium to rarer medium. That's what we see here. Yeah. The ray of light is traveling from denser medium to rarer medium. So this is our first condition. And second condition is what? The angle of incidence means CON dash should be greater than the critical angle. Should be greater. Here it is greater, no? See, the angle of incidence. The angle of incidence in this case, the angle of incidence is what? C and O and N dash. The angle of incidence. And this angle of incidence is more than the critical angle. What is the critical angle in our case here? C. Critical angle BON dash. BON dash is the critical angle. BON dash is the critical angle. BON dash. So of course, angle CON dash is more than angle BON dash, which is the critical angle. So these are the two conditions. So did I tell you anything new? Nothing, no. Everything already we have discussed. Alright? So the concept should be clear. The concept, yes. There are two mediums. The ray is traveling. Imagine. There are two mediums. The denser medium, rarer medium. The rays are traveling like this. Gradually the angle of incidence increases. And now in a particular case, this happens. Alright. So once again I am repeating the conditions for TIR. First, the ray should travel from denser medium to rarer medium. Second, the angle of incidence in the denser medium should be greater than the critical angle. Okay, fine, clear. Good. Now the last question for today: what is the relation between mu and C? Mu, the refractive index, and C. Alright, a very simple and important relation is mu is equal to 1 upon sine C. Mu is equal to 1 upon sine C. Mu is equal to 1 upon sine C, or you can write down 1 upon sine C as cosec C. 1 upon sine C is cosec C. So mu is equal to cosec C, or mu is equal to 1 upon sine C. Alright. So this was the last question for today. Mu is equal to 1 upon sine C. Hope things are very, very clear. Alright. Then thank you so much. Thanks. And one second. After this we have TIR in prism. TIR in a prism. Alright. In that continuation. So that I'll do in part 3 next time. TIR, total internal reflection in a prism. Now there are 3 types of prism. Alright. So in each type separately we will discuss what's happening, how the TIR is taking place. Alright. Fine then. So that you will see in part 3 very soon. And thank you so much. Thanks.